if a unit vector is represented by 0.5 I cap plus 0.8 j cap plus c k cap, then the value of c is, if this vector is unit vector, if this vector is unit vector, its modulus should be 1, but its modulus is square root of 0.5 square plus 0.8 square plus c square, but it should be 1. So what we are getting? 0.25 plus 0.64. So we are getting c square is equals to 1 minus, add these two, 5 and 4, 9, 6 and 2, 8. So we are getting, write it 1.00, 0.11. So what is c? It should be square root of 0.11. So we are going with option B. 35th. The angle between the vectors A and B is theta. The value of the product of B cross A dot A is equal to, it is only a conceptual problem. Two concepts they are merging. We know that the dot product of two vectors is 0 if they are mutually perpendicular to each other, due to that cos theta, because cos 90 is always 0. The second concept they are merging in this is this, that cross product of two vectors is always perpendicular to that plane in which they lies. So cross product of B and A, either it is A cross B or it is B cross A. It should be perpendicular to the plane in which A and B lies. So dot product of B cross A and A, it means dot product of two vectors which are mutually perpendicular, because B cross A is perpendicular to both A as well as B. So their dot product should be 0. So we are going with option D. Next, a car is moving along a straight road with a uniform acceleration. It passes through 2 points P and Q, separated by a distance with velocity 30 km per hour and 40 km per hour respectively. The velocity of the car midway between P and Q is, with different numbers. They ask this problem so many times. Why? Students are thinking कि velocity at P is 30, velocity at Q is 40. So at midpoint it should be 30 plus 40 divided by 2, 35 km per hour. But no. Particle is moving with uniform acceleration. So we have to calculate with the Galileo's equation. C. It is point P. I am taking velocity at this point U. They gave the value of U 30 km per hour. In last we will put this. I am giving you formula first. At Q, I am supposing the velocity V, and distance between P and Q is 2s, means it should be midpoint. This distance is s, and also this distance is s. Particle is moving with uniform acceleration a. So I am applying the third equation of motion between P and C. At C, I am supposing its velocity capital V. So V square is equals to U square plus 2AS. Now I am applying this formula between C and Q. Final velocity is small v. Initial is capital V. Distance is same, acceleration is same. Subtracting one relation from another, it is 1, it is 2. 1 minus 2 means V square minus V square on left hand side and U square minus V square on right hand side. So I am getting 2V square is equals to U square plus V square. So what we are getting for V? Square root of this. Now by putting the value of U and V, it was 30 square, it was 40 square, means 900 plus 1600, it is 2500. So take 50 out of the root, multiply numerator and denominator by root 2, we will get 50 root 2 by 2 means 25 root 2 kilometer per hour. So we are going with option C, not with D, 35 kilometer per hour. 37th. A boat is sent across a river with a velocity of 80 kilometer per hour. If the resultant velocity of boat is 10 kilometer per hour, the velocity of river is. Now, there are two vectors. You sent the boat across a river, means perpendicular to river, with velocity 8 kilometer per hour. Suppose velocity of river is U kilometer per hour. What should be resultant? We know the formula for resultant. R square is equals to 1 vector square plus Q square plus 2PQ cos alpha. In this problem, this gave us the resultant. What is the value of resultant? It is 10 kilometer per hour. So square of R, square of 10 is 100. P square, it is 64. We want to calculate Q. It is 0 because alpha is 90 degree. So Q square means 100 minus 64, 36. So Q should be 6 kilometer per hour. So going with B. 2 times they asked, 93 and continuation in 94. Next, 38. A particle moves along a straight line such that its displacement at any time t is given by s is equals to t cube minus 6t square this. The velocity when the acceleration is 0 is, first we have to go for velocity, but we want to calculate velocity when acceleration was 0. So we have to calculate when acceleration was 0. At that time we want to calculate velocity. You know that rate of change of displacement is velocity. So what is velocity? ds by dt. S is given, so differentiate that. So it is the expression for velocity. Differentiate this and calculate the expression for acceleration. We know that acceleration is rate of change of velocity. So it should be 60 minus 12. When acceleration is 0, when it was 0, it was 0 at t is equals to 2 seconds. It means we want to calculate velocity at t is equals to 2 seconds. So from 1, we are able to calculate that. Put in that relation t is equals to 2. 2 square means 4. So what we are getting? 12 minus 24 plus 3. 12, 3, 15. 15 minus 24 minus 9 meter per second. So we are going with option C. We are going with option C. 39th. The displacement time graph of moving particle is shown below. The instantaneous velocity of the particle is negative at the point. We know the theory. What is the theory? Ki in displacement time graph, at any point, tangent will give you the direction of velocity, and the slope of tangent will give you the magnitude of that velocity. Velocity is given by slope of tangent at any point in displacement time curve. In displacement time curve, at any point, slope will give you the slope means tan theta, the velocity. If you draw a tangent at C, it will make an acute angle with time axis. Same picture is at D. If you are drawing a tangent at D, it will again make an acute angle with the positive direction of time axis. And tan theta, if theta is acute, should be positive. If you are drawing a tangent at F, again it will make an acute angle, but only at E it will make an obtuse angle. So only its tangent is negative. So we are going with option D. Next. A train of 150 meter length is going towards north direction at a speed of 10 meter per second. A parrot flies at the speed of 5 meter per second towards south direction. Parallel to the railway track, the time taken by the parrot to cross the train is. What we want to calculate? First, we will calculate the velocity of train with respect to parrot. For parrot, by what distance train is moving? If I am putting the velocity of parrot 0, what is the velocity of train for that parrot? We want to calculate velocity of train with respect to parrot. What we have to do? Train is moving in the direction of north with speed 10 meter per second. If I am taking the north direction positive, south should be negative, but when I will reverse the direction of parrot, it will again in north, so it will become positive. So both are now in same direction, so we have to add them. So what we are getting? 15 meter per second. So with this speed, it has to cross a distance of 150 meter. We know that what is time? Distance upon speed. So 150 by 15, so we are getting 10 seconds. Train will cross the parrot in 10 seconds. 41st. The maximum range of a gun of horizontal train is 16 km. If g is 10 meter per second square, then the muzzle velocity of a shell must be. The maximum range of a gun of horizontal train is 16 km. If g is equals to 10 meter per second square, then the muzzle velocity, you set your gun for maximum range. I told you what is the formula for maximum range. It should be u square upon g. I told you in theory just before starting these problems. So in this problem, what things are given? R is 16 km, means 16,000 meter, into g, g is 10. So in SI units, we are getting u square. One 160,000. So what should be square root? Square root of 16,4, take 20 meter per second. So we are going with option C. If a body A of mass m is thrown with velocity v at an angle of 30 degree to the horizontal, and another body B, same mass, thrown with the same speed at an angle of 60 degree, the ratio of horizontal range of A to B will be, 2 times they ask this. First I am giving you the concept. What was the formula for horizontal range? See, it was u square sine 2 theta by g. It is the formula for range. Now I am throwing this object at an angle 90 minus theta, means I am replacing theta by 90 minus theta. We want to see what is the change in horizontal range. I am putting it now r dash. So r dash should be with same speed, I throw same projectile but at a different angle. Now new angle was 90 minus theta. First I throw the projectile at an angle theta and I got a horizontal range u square sine 2 theta by g. Again at same place with same speed I am throwing that same projectile but now at an angle 90 minus theta. I want to see what is the range now. Sine 2 90 minus theta. What I am getting now? It is sine 180 minus 2 theta divided by g. But sine 180 minus 2 theta is sine theta. So what happened? I got same result. It means there are two angles with which you throw the object. You will get same range. Either throw at theta angle or throw at 90 minus theta angle. Horizontal range will be same. What is the special in these two angles? Sum of these two angles is 90 degree. So remember always, if for horizontal range only there is a difference in angles, but sum of angles is 90, horizontal range will be same. In this problem, first you throw at an angle 30 degree, then at an angle 60 degree. Since sum of both angles is 90 degree, so range should be same. So ratio will be 1:1. So we are going with 1:1. Next, two projectiles of same mass and with same velocity are thrown at an angle 60 degree and 30 degree. Then which will remain same? Just I explain you. Since again in this case, sum of two angles is 90 degree and you are throwing with same velocity, so horizontal range should be same. So range of projectile should be same. A particle is A is dropped from a height and another particle B is projected in horizontal direction with speed 5 meters per second from the same height. Particle A will reach. What is the situation? You are standing here at height h. A particle A, you dropped, and another B, you throw with some velocity in a horizontal direction. Particle is moving towards ground due to gravity, and gravity will produce a constant acceleration on both the packets, both the particles. So it is the motion under constant acceleration in a straight line. What time it will consume to reach the particle to ground? We can calculate that with the help of Galileo's equation, ut plus half gt square. H is same for both. This packet you dropped, so for packet A u was 0. But you throw this second particle in horizontal direction, so its component at this angle, it should be again 0, because we know that in a vector, if it is making an angle theta with x-axis, its horizontal component is given by, its horizontal component is always given by f cos theta, and vertical component, it is given by f sin theta. If theta is 90, this component will become 0. So initial velocity in downward direction for both is 0. So h is same, u is same, g is same. How to t can be differed? So they will reach simultaneously. So we are going with option C. This concept we are using 4-5 times we saw. 2 times same problem they gave. Angle of projection of a projectile at an angle 45 minus theta and 45 plus theta. The horizontal range described by the projectile are in the ratio of, again we are seeing that sum of these two angles is 90 degree. So horizontal range should be same for both. It means we are going with option B, 1:1. So getting my point, in this way We solved so many problems from previous years. So almost if you see the theory slides, my lectures for class 11th, with this crash course lectures, I have completed the last 30-35 years each and every problem, and I explained you they are not asking tough problems, they are attacking only basic concepts. So no need to go for big calculation problems, only make your concepts strong, you will get admission. Thank you.